Alright, hello. So, what we're going to be talking about today is a thing called an object. And specifically how to make a class so that it can be properly used as an object in another program. And I think we're just going to go ahead and do a house. Alright, so all throughout this class, you have made many public classes, right? Well, we're going to do that again, but this time there's going to be there's a difference. The difference is going to be that we're going to use this less like a program, as if it were a program itself, and instead more like an object to be used somewhere else. So I'm going to close out of this one. What I'm going to do is, at the end step of this, I'm going to pause on creating the house, and I'm going to go and look at the actual creation thing I'm going to have with public class neighborhood. Alright, now with this one, we're going to have this actually be where we run our program from. And in here will be a house array. Now that sounds kind of weird, but we'll go into what we mean by that. Alright, so this is going to be an array of houses. Now what is a house? A house is an object. It is an object that I just made. Right here. Now, what does a house have in it? Well, right now it's blank. But we're going to go ahead and write the blueprints for the house. So, in this case, we have to think about what kinds of things a house has. And I'm going to make this little thing called member fields. It's basically private variables. And what I mean by that is literally that we're going to have things like private, integer, height. So you're familiar with this, at least, having a variable. Usually you have it inside a method of some sort, but in this case we're having it out in the interstitial fluid of the class itself. And this private thing is kind of new, but this is what we call a private member field. A member field is a variable declared in the class, but not inside of an object. Not inside of a method. And what it basically means is that when I make one of these houses, like I make the first house, is a new house, that one now has its own height that I can work with. Accessed sort of like this. We're going to discuss why this won't work, because if I were to try and change it like this and compile it, it's going to tell me it has private access, in which case I'm not allowed to use it directly. We should keep it as private. I'm going to change it to public for just a moment to show you how that works, and then how I can go ahead and print out that house's height. Now, if I were to try the next house's height, well, it's going to tell me that that house hasn't been made yet, and it'll crash with this null pointer exception. Null is like 0 for objects. Notice how I haven't done houses at 1 equals new house? Well, that's why we aren't able to change anything about houses at 1. It's a null pointer, because in that place in memory where houses at 1 is supposed to be, there's this thing called null. Alright, we're going to change this back to private, so that way it won't let me compile anymore on either line. And what we're going to do is we're going to make some accessors and mutators, also called setters and getters. Alright, so a setter is going to be the thing that sets one of these member fields. So for each member field that I make, and I'm going to make a couple of them right now, private int Actually, we'll do, yeah, we'll do double square feet. I don't actually know what else a house involves. I have an apartment. So we'll just do this. That much would be fine. Oh, you know what? String, color. Private string color. Now for each of these, I should have an accessor and mutator. I'm just going to do it for the first one and let you kind of figure out the rest from there. So a setter, and I put this wrong. The getters are the accessors. The setters are the mutators. So for the first one, I'm going to do public, and I'm going to do the mutator first. Public void set height. And when I set it, I have to give it some kind of parameter because I'm setting it to something. So it's just going to be something that the user wants me to put in. So I'm going to go, okay, new, I'm going to go, okay, height equals new height. And with that, I have mutated whatever object I'm dealing with. I've mutated the height of it, its height, by setting it to whatever the new height is. Meaning that now, instead of this broken line here, I can go set height, and then pass it, because it's a method, pass it that 6. Now this line is fine. I'm going to do something similar. Public int get height, and this is going to be my accessor that accesses it. It doesn't take anything for parameters, but it does return an integer. So we got the return type int, and it's going to return height. And with that, now instead of printing height, because it is private access and so I can't see it, I can use the method get height, and now it works just fine. Now the fact that we use these member fields that are private and these accessors and mutators that are public is what's called encapsulation. Encapsulation. In encapsulation, we do proper object-oriented programming where you have member fields that are only accessible within the class, meaning only these methods that are written inside the class can actually change these private variables. And you have accessors and mutators that allow other classes, like neighborhood here, to change the variables because they work through those things. Now, it may not be exactly clear to you why we're doing it like this, but here, let me go ahead and make some changes to my setter. For instance, let's say that we wanted to make sure that the user only put in new heights that were greater than 0. That would prevent me from, changing it to something like, negative 43. So it would still print out the 6 because that was greater than 0. Typically, though, we don't have a condition in there, but we can. And that's kind of the reason why we would use mutators. Listen to me right now. Typically, you will not put anything like this in there. You will just have the setter on its own. That is typically what you would do, in which case any set would actually work exactly as written. You do not have to put this in there most of the time, only if it's asked for. Okay. But that is encapsulation, and that's what encapsulation can allow for. Changes being made to how anything is set or returned. All right. The rest of it would work kind of like you expect. We're going to get into constructors. A constructor is, well, let me first show you a call to a constructor. Right here. This new house and then empty parentheses, that means that house actually has a constructor already. You see, whenever you make a new public class, you get a new constructor, which is simply titled the name of that class with empty parentheses, and it does nothing, but it allows for this new thing to be done. Neighborhood even has one. Like if I had to do neighborhood x equals new neighborhood, you'll see that that works just fine. You can run, works, nothing happens, right? Whenever you make a constructor for a make a constructor for it, and you start changing it from the default empty one, like if I wanted to go and get in the height, the square feet of the house, and the color. Once I do that, now this no longer works. You might be confused because you didn't remove anything, but what you did do at this point, or what I did, was by making a different constructor that looks different from the default one, which is empty parentheses, I now have gotten rid of the default. If I wanted, I could make a second constructor that was just the default one to replace it. And again, this is not something you typically do. But it's something you could do. But what I'd usually do is I'd use this constructor to actually build the object. Now, you might still be thinking about this as this is the house, but it's not. It's one of 10 houses, and each of these houses are going to be given a height, a square footage, and a color. And with that, we're going to make 10 houses. I'm going to just do the first 2 for right now. And it's not going to really have anything because it's not going to actually change the height or anything about the houses. So what I do is, in the constructor itself, I look at these member fields, and then since they're private, I can set them within this class. So that's how I can change things like the height, I can change the square footage, and I can change the color. Now, hang on there. Pause a moment. The name of this variable, so far the parameters here have had variables that have different names from the member fields, right? Good. So this last one though, this parameter has the same exact name. So when we say color equals color, well, do we mean this one or this one? Technically, both of these are actually referring to this one because we are within the place where that was declared. So what we do is, to make sure that this one on the left here is our member variable, our member field, and not this parameter, we say this dot color. This dot makes it so that way it's referring to just these private variables up here. Now when I do that, let's see, it compiles, and then it runs okay. But what we're going to do now is we're actually going to go ahead and add a loop, and we're going to go through all of the things in the houses neighborhood, in all 10 houses. And it at least has the first 2 made because I've constructed them. The others have not been constructed, so they're still null. I could go through making the rest of the houses. This is going to be black. And what I'm going to do is next, I'm going to go ahead and remove some houses, make just 4. So that way we don't have to go on too far here. These are big houses. And that'll at least allow us to go through all 4 houses in the neighborhood. So each of these constructors does the job of the accessors and mutators. Alright, I'm going to go a little more quickly. Accessors and mutators can still be used on each of these objects. Set height to, let's see, house 2, it's going to be now 600. And I can print them out again, and you'll see that this time around, First time, that's how big they were. The second time, that one right there has been changed to 600. So setters and getters, or mutators and accessors, and constructors make the three main parts of a class. All right, I think that's about all I really want to tell you about that. The lab to go with this is the bookshelf lab, in which case you'll be using this book right here. This book that was already made, having two member fields, a constructor that set them both, accessors. It doesn't have a mutator, but that's kind of done here. You can add in the mutator if you like. And if you wanted to add in that setter, it'd be look just like that, public, void, set whatever, make sure to give it a parameter, and then actually change it. Yeah, so that's going to be the book for the bookshelves. You'll also be doing an array there. There'll be a two-dimensional array. So it's kind of like this one, but 2 dimensions. And of course you have to make more of these. Alright, so and of course all this code now won't work because it's a 2-dimensional array. But that is how you work with objects. Each of these objects is now able to contain multiple values inside of them. So that way, especially when you guys are thinking about things like games, or if, for instance, you want to build your own Strelekis practice environment, I keep an object for the user that's currently using the practice environment. You know, things like that. It just keeps variables collected. It's basically, it's almost like having an array of values, but that each of those values can be different. So that's going to be actually with 2D arrays and with objects. Just adding this brief aside in here. When you have 2D arrays and objects well understood, you have the bulk, really. You have the bulk of AP Computer Science A. Just the biggest part of it is focused on object-oriented programming and on moving through collections of data. Those are two of the biggest concepts I really want you to have. So these are some of the most important lessons. Please ask me if any questions. Hope you enjoyed the video. Ring that bell, subscribe, like. Nah, I'm kidding. But thank you for watching. See ya.